Okay, so this is the correction of the homework for second years, page 406, questions 3 to 8. It's all to do with rates of flow. Okay, so first question, question 3. A rectangular oil tank with dimensions 60, 100 and 100, as shown, has a hole in it and is losing oil at a rate of 3.6 litres per hour. That's the first thing we know. And it says find the rate at which the oil level is falling. So find oil rate falling in centimeters per minute. Okay, so the first problem we have is this is litres and we want it in centimeters, and it's per hour and we want it in minutes. So what we will do is we will take this 3.6 and it's in litres, we want it in centimeters, so we multiply it by 1000. So 3.6 multiplied by 1000 is 36,000 centimeters cubed. Okay, so 36 centimeters cubed and 3,600 centimeters cubed amount of oil it loses per hour. Right? However, we're not interested in per hour, we want per minute. So we'll divide that by 60. And we get 60. So, losing 60 centimeters cubed per minute of oil. Right, so I'm going to draw the amount of oil it's losing, okay, in the shape that it's losing it in the tank. So the tank is 100 long and it's 60 wide. Okay. And we don't know then, because I suppose the shape of that is not changing, but we don't know the height of it because we don't know how much is lost. Okay, so we have to find out the height here, or the rate at which the oil is falling. Right, so okay, so here's what we're going to do. We're going to take the length, which is 100, multiplied by the width, which is 60, multiply by the height, which we don't know. And if we multiply all these three together, then we should get 60 centimeters cubed. 60. We divide by 60 on both sides. Okay, so we divide by 60, divide by 60. We will get 100 multiplied by h equals 1. Divide by 100. Divide by 100. And we will get h equals 0.01 centimeters. Okay, so that's the rate at which it's dropping. So every minute it's dropping this much. Okay, and back of the book says something different actually. So you can find out what they did. And a little test for you. Okay, do. Right, question 4. Water is flowing at a rate of 10 centimeters squared per second into a cylinder with diameter 30, so we'll say radius 15. Find the rate at which the water is rising in centimeters per second. Okay. This is quite an easy one. So in 1 second, it says 10 centimeters cubed per second, it's flowing. So that means if there was a tap here, flowing water in, and I turned it on for 1 second, how much water would be in here? Well, according to this, at this flow, 10 centimeters cubed. So now I have the volume, 10 centimeters cubed, I have the radius, and I want to find the height. Okay? The height, it has risen in a second. Okay? So here we go. Volume equals pi r squared h. We know that the volume after a second is 10. Pi multiplied by the radius squared, which I don't know. Or sorry, I do know. 15. And then the height, which I don't know, is what I'm trying to find. Okay, I'm trying to find the rate at which it's rising. So the height, it's risen after a second. So 15 multiplied by 15 is 75. So 10 pi multiplied by 75 multiplied by h multiplied by pi on both sides. You get 3.18 equals 75 multiplied by h. 3.18 divided by 75 equals 0.00424. That equals the height. Sorry, actually, I just noticed something there. 15 squared is not 75, so can I go back? Sorry about that, guys. I don't know what I was doing there. 15 multiplied by 15 is 225 multiplied by h. Okay, so divide by pi on both sides. So 10 divided by pi is 318 equals 225 multiplied by h, divide by 225 on both sides. So 3.18 divided by 225 equals 0.014 h, and that is centimeters. So 0.014 centimeters per second. Okay. Alright, and actually this one I should have said height equals 0.01 centimeters per second. Okay, so that's that done. Okay, question 5. Just from the off, I don't like this question. Okay, a few reasons why I don't like it, but anyway, and it's not that I don't like it because it's hard. I don't like it because of the way it's phrased, and it says how many litres of rain per second must pass through the drain to prevent flooding. Well, we have to presume then that it floods, like floods outside the car park. That's what I'm presuming here, and also that over 10 centimeters of rain, then it floods. Okay, so but anyway, we won't get into that. Right, car park has a drain at its centre for rainfall. The car park measures 18 metres multiplied by 60 metres. During a storm, 10 centimetres of rainfall in 1 hour. How many litres of rain per second must pass through the drain to prevent flooding? Okay, we want to get litres per second. We have metres and per hour. So the first thing is I'm going to get the area of the car park. 18 metres multiplied by 60 metres. But I'm going to do it in centimetres, so it's 1,800 metres by 6,000 metres, and that is 1800 multiplied by 600 equals 10,800. So it's 10,800,000 centimetres squared. Okay, and then it says during a storm 10 centimetres of rain falls, so that means we have our area of the car park and then 10 centimetres. I didn't draw that great now, but if you can imagine the area of the car park and then 10 centimetres of rain fell. So if I get the volume of rain that falls, I'll have to multiply this by 10 and I get 108,000,000 centimetres cubed rain fell Now, it says 1 litre is 1,000 centimetres cubed. So I'm going to change this centimetre squared into litres, or centimetres cubed into litres. So 108,000,000,000,000 divided by 1,000. Well, you just knock off the last 3 zeros. So it's 108,000 litres. So 108,000 litres fell in an hour. But they're looking for the litres per second. So if that much fell in an hour, this is an hour, if we divide by 60, we get that much, 1,800 litres in a minute. And we'll get, divided by 60 again, 30 litres per second. So 30 litres per second fell, right? So in order for the car park not to overflow, this hole must allow 30 litres per second go through it. Okay, so 30 litres per second is the answer. Okay, thanks. Okay, so question 6. Water is flowing from a cylindrical tube of radius 2. So there it is, radius 2, doesn't matter the height. And it's going into a bigger one of radius 8. And it's saying the rate of flow from the smaller one is 4 centimetres per second. Alright, and it's looking then at what rate of flow is in the big one. So basically, water is going here, 4 centimetres of water is passing through here. So look, let's just say 4 centimetres of it there. Okay, there's 4 centimetres of that, and it goes down here, and we're wondering then, if it's 4 centimetres of it here in a second, how much is it here? What's the height there? Okay, so here's what I'll do. I'll just take it at 1 second. That's the easiest one. So in 1 second, in the smaller one, I want to find the volume of water. Okay, so this here is 4, the radius is 2. So that much water goes in there into the small one, or passes through the small one after 1 second. And get the volume of water then. So pi r squared h volume equals pi multiplied by r, which is 2 squared multiplied by 4, volume equals 16 pi centimetres cubed, and I'll let it at pi. So that's how much water passed through the small one after 1 second. Now the same volume of water is going to go down here, and in 1 second I'm looking at how much water, how the height of water that's going to be here. Same volume of water will be a different height though. Height here is 4. I wonder what that amount of water down here will give us a height of. Let's see. Same, it'll be volume equals pi r squared h, and the volume we know is 16 pi equals pi multiplied by r is 8 squared multiplied by h. Cancel the pi's. 16 equals 8 squared is 64 multiplied by the height. Divide by 64 on both sides. And we have 16 divided by 64 equals 0.25 equals h. So we have 0.25 centimetres per second. So in 1 second, the height of this is going to rise 0.25 centimetres. Okay. Okay, question 7. Finn said it took 1 minute and 60 seconds for the sink of water to empty completely. The radius of the hemispherical sink was 18 centimeters. Okay, I'll draw this hemisphere. 18 centimeters radius. And down here, it's radius 3 for the tube or the pipe. Find the volume of water in the sink. Right. So the first thing I presume is that the sink is full completely. It doesn't actually say that. It says, like again, the book is it's iffy enough with these questions. I'll just read it again. Finn said it took 1 minute and 20 seconds for a sink of water to empty completely. Okay, now they should really say a full sink of water to empty completely. But anyway, right. Volume of water in the sink. Okay, this is easy. It's a hemisphere with radius 18. So volume equals 4/3 is a full sphere, 2/3 is a hemisphere, so 2/3 pi r cubed. And the radius is 18, so I put 18 in. So 18 by 18 by 18 and divided by 3, multiplied by 2, and we get 3,888 pi. So that's the volume of the sink. They don't tell us whether they want it in terms of pi or anything, so I'll just leave it as pi. So 3,888 centimeters cubed. Okay, if you want to change it to just decimal, it'll be 12208.32 centimeters cubed. Okay, so it took 1 minute and 20 seconds for that to empty completely. So how much water was leaving after 1 second? Because the next question says the volume of water passing through the waste pipe per second. So I want to know how much water is leaving that per second. Okay, I know that at 1 minute 20 seconds the whole lot of it leaves, the 12208.32 centimeters cubed. But how much is leaving per second? Well, 60 and 20 is in 80 seconds this much leaves. So in order to find out the volume that leaves per second through the pipe, I'll take this 12208.32 and I'll divide it by 80 and I get 152.60. 8 rounded to 2 decimal places. So the volume of water passing through the waste pipe per second, this much. And then they want to find the rate at which the water is passing through the pipe in centimeters per second. So what they mean by that is, this is the pipe. After 1 second, how much water goes through it. Okay, and how we'll do that is we'll find the height of water when the volume is that much. Okay, this is the way we do these questions. You'll see it the same the whole time. We're talking about height. When we talk about the rate, we're looking for the height. Okay, so 152.60 centimeters cubed. That's the volume of that. We know the radius of it. 3. We want to know the height of it. Okay, we want to know the height of water that passes through after a second. So volume equals pi r squared. H, we know the volume, 152.60 equals pi, we put it 3.14 because we don't have another pi over here to cancel it, so we leave it as 3.14. Multiply by the radius squared, 3 squared is 9, multiply by the height. We take the 152.60 and we divide it by 3.14 on both sides. Okay, so divided by 3.14 on both sides and we will get 48.60. That equals 9 multiplied by h, and then divide 48.60 divided by 9 and we get 5.4 equals the height. So the rate at which the water is passing through the pipe in centimeters per second is 5.4 centimeters per second. Okay. Okay, last question. It says the water tank in the attic measures 50 high, 50 wide, 100 long. Okay, I'll draw it. 100 long, 50, and 50. Okay, when the ball cock is fully opened, the water in the tank rises at a rate of 5 centimeters per 1 minute. Find how many litres are passing through the inlet pipe per second. Okay, so we have that tank, but that doesn't really matter as such. We're not interested really in the height. What we are interested in is that after 1 minute, it rises 5 centimeters. So I'm just interested in this bit here, this 5 centimeter bit. So I'm going to redraw this. And I don't really care about the height of the tank. What I do care about is this bit of water in the tank, which is 5 centimeters high. Okay, that's how much water has gone in there after 1 minute. So I'm going to get the volume of water that went in there after 1 minute. So it's 100 multiplied by 50 multiplied by 5, and it's 25000 centimeters cubed of water per minute. Now they want to know how much water is going through the inlet pipe per second, and the pipe is most pipes are cylinders. But first of all, they want to know how much is going per second. Why have it per minute? So I'm going to have to divide this 25000 by 60, and I get 416.66 centimeters cubed per second. So that much water is passing through that pipe every second. And they want to find how many litres are passing through the inlet pipe per second. Okay. Well, I know how many centimeters cubed are passing through, and I know that 1 litre equals 1000 centimeters cubed. So if 1000 centimeters cubed. So if I divide this by 1000, so 416.66 divided by 1000, I will get 41.66 litres. Okay, that's it, guys. This is tricky. This is the trickiest part of the area and volume section. Alright, don't worry too much if it's confusing. Okay, some of the questions can be tricky, but don't worry too much, okay, because it's not something that comes up that often in exams. Alright, thanks, guys.